Hello, everyone. Welcome. So today we're just going to have a quick little demo about how to use Excel for graphing and math because I find a lot of students just have trouble with it, or they're not familiar with it, or it's brand new to them. But it is a valuable skill that you really should learn how to do and master. You should never be afraid of using a computer to make your life easier. Trust me, it'll save you a lot of time. So let's dive in. So what we have first up is actually, let me delete this. And this, since we're working on it, we have our table here. So the density of cylinders. So remember, we took physical measurements of these cylinders. We took volume measurements of these cylinders with water. So let's talk about what we do with that data. So in Excel here, I've given us a hypothetical data set, the same as yours, but these numbers are completely made up. So if you don't get exactly what I get, it's because your data doesn't look like mine. And my data is not real, your data is real. So just don't worry about that. So the first thing we need to do is calculate volume. Now, as you saw in the protocol, the volume of a cylinder is pi times radius squared times the height. Now, we calculated the height, which is the length. So that's the first piece of information we need, is the length or the height. We have the diameter, which is 2 times the radius, as I've sort of noted here. That's what the diameter is, the radius times 2. And we also have the mass here on this column B. So let's talk about how to do some math and make our lives 1,000 times easier. So for those of you that have done Excel math, you know to do math in Excel, you simply start off with the equal sign. You have to do it. If you don't do the equal sign, it does not work. So let's do our first thing. Let's enter pi. Now pi, as you guys probably know, is just a number. It's 3.14, and it repeats a bajillion times. So we'll just enter 3.14 for simplicity's sake. Next, we want to select height. Now what we'll do is select centimeters here, length in centimeters. And all we have to do is just click the cell, and Excel knows that it's going to select that number in the cell. Then we want to hit it another multiplication sign, so it's got asterisk, so that's Shift 8, just if you're on a regular standard English computer. And we want to actually add in radius squared. So, but to do that, we actually have to do a little bit of a calculation first. So the way we do this is we open 2 parentheses. And we take the diameter, and we're actually going to click it. So it will select cell F2, and we'll do the backslash divided by 2. And then we're going to close that first parentheses. So that's Shift 0, just as an FYI. Then what we want to do is, because it needs to be squared, we're going to click Shift 6 and put the little upwards widget and select number 2. And then we'll close that second set of parentheses, finishing off our equation. Pi times height, or in our case, we've labeled it length, so they're the same thing, times the radius squared. And so I'll leave this little equation up for about 10 to 15 seconds so you can copy it down or put it in your own Excel sheet or whatever you need to do. Or ignore it, whatever you feel like doing. All right, when you're done with your math, you simply hit enter and it'll do the equation for you. Now, we could type that equation over and over and over again, but we're lazy. So let's move our mouse cursor over to this box in the corner. You notice mine turns into a little bullseye. It should do the same thing on every platform, whether it's Excel or Apple's numbers. You click that little box and you drag it down, and it will actually apply the equation to every single row. So making your life a lot easier. So that's the first thing we need to do. Then we want to calculate density, which is simply mass divided by volume. So we start off with the equal sign again. We select our mass, we hit the backslash to divide, and we click the volume. We click enter, and we get a number. You guys can take a peek at this formula right up here. That's B2, so cell B2 divided by cell G2. And I'll upload this to Blackboard as well, so you don't have to technically copy it down if you don't want to. And then like we did in column G, we're going to drag down and apply the math across the board. So that's pretty straightforward, pretty handy. Now we have our final one, which we want to calculate density in grams per milliliter. So what we want to take advantage of is these 2 columns, right? So I'll color these in green, just so we know they're all the same, right? So we want to do another equal sign. We'll select our mass again, and we're going to hit divide. And what we're actually going to do is open another set of parentheses. Now, our volume that we were interested in is how much volume the object has. So to do that, we need to subtract from this volume, which is the volume of water, plus the volume of the object together in the cylinder, minus the amount of volume of water that we started with. We're going to close parentheses and hit enter again, and you can see the equation we did here. B2, which is mass, divided by D2 minus C2, which is our change in volume because of the cylinder. From there, we're going to drag it down again, finishing off our calculations. So bing, bang, boom, our calculation is done. Now, you can type all these into your worksheet if you want, but the easier thing to do actually would just be to copy the whole thing, come back to your worksheet, delete this bad boy, and actually just paste it in. Click paste on linked here. And you see that the worksheet has the thing in it now. Now, I wouldn't add colors like I have here, but that was just to help sort of illustrate what I was working on at a given time. So that's part one, the density of the cylinders. Now, we have the math, and it's easy math. And again, this math is applicable to pretty much everything you do in the rest of the course. So again, it's a great skill to learn. Now, the way I've done it in Excel, Google Sheets here, it's the exact same way you would do it in Excel or numbers. They're all exactly the same. So you don't need to worry about what I'm showing you not being applicable to you if you say use a Mac. But the other reason I did it in Google Sheets is because everyone can access Google Sheets. Everyone probably has a Gmail, or if you don't have a Gmail, you can sign up one for free and go use Google Sheets if you want. So then we want to scroll down here to the end of the worksheet where we have questions. So in Excel or a similar program, you create a scatter plot. Now you can click this link to learn how to create a scatter plot and learn about scatter plots. But I'm just going to show you how to do it. So what we want is actually volume on the x-axis and mass on the y-axis. So what I did is I actually copy and paste it into a brand new sheet. If you don't know how to create a new sheet, you see this link down here at the bottom, you click it and it adds a brand new sheet. I'm just going to delete it because I don't like clutter. So what I did is I copied my mass and volume into the sheet. So in column A, I had my mass. In column B, I had column A, I had my volume. In column A, I had my mass. B, I had my mass. Sorry. If you don't know how to do those things, you would just select it. So you click on a cell that you're interested and just click and hold and drag down. And then you can right click and copy and then paste again. So just as an FYI. Now, to create a graph, and again, this is the similar across all computer programs that do this type of thing. We want to select both columns like this. So I just want to click on that cell, hold the click in, and drag all the way down, selecting all of my data. Then what I want to do is go to Insert. And again, this will be the same on Excel and Apple's numbers too. Go to Chart. And again, what I want to do first is actually see this little right-hand menu on Google Sheets. So what I want to do is actually click Chart Type. Now it's suggesting a scatter plot, but I'm actually going to ignore that because I want to show you how to do it in case it doesn't suggest a scatter plot. So what we're actually going to do is scroll down, and we're actually going to find our scatter plot right here. So we'll click on that scatter plot, and it's already actually kind of done a nice job for us. It's labeled the axes. Now you want to make sure you always label the axes. So it's actually in vol, but I'm actually going to change it. So if you double click on it, I should say, you can just fix the thing so it says volume, not vol. But it's important to make sure you have axes, right? Because without axes, it just could be gorillas, right? So it could be anything. So we need to make sure we have labels as we have here. So volume on the x-axis, mass on the y-axis. Now the other thing we want to do is we're going to sort of close that little thing down, and we're actually going to select series here. So we're going to click series, and you'll notice under series, you could change the point color if you wanted, for instance, like you can change this to black if you wanted to, it won't really matter. But what we're actually interested in is scrolling down here and actually clicking this box here called a trend line. So we're going to click trend line, and what we're going to do is select its label, use equation, and then we're going to select this final box here called show R squared value. And so that's pretty much it. Now, you don't need a chart title. So I always recommend people delete chart titles because they're not necessary in this course. Some professors will require a chart title. I hate chart titles. So if you have them, cool. If you don't, even cooler. And so I have this graph, and this is the answer to question number 7. So I can copy this graph. So I just said Control C, that's a copy on a computer, and I pasted it here. So when you're putting a graph for this course or any other time you do it, and I'm your professor, you need to make sure you do one of two things. You need to copy and paste the graph directly from Excel, or you need to take a screenshot. And if you don't know how to take a screenshot on your computer, just Google how to take a screenshot on a Mac, a PC, Windows, whatever you want to do, whatever operating system you're on. Just Google how to do it. Because if you put a picture with your phone, I'm going to give you 0 on the question because phone pictures suck. That's just the end of the story. So take a picture with your computer, screenshot or copy and paste it, no cell phone pictures. And there's no like ifs, ands, or buts about that. So now that's question number 7 done. As long as you have this the way it is, you're A-okay. Now, question 8 says, in a calculator linear regression, and paste the R-squared value below. Now, I already have the R-squared value in this thing, but I'm going to enter it one more time because that's what the question is asking for. Now, the R-squared value is a really interesting metric. The R-squared value tells you about the goodness of fit of your line. Now, let's go back to Excel. You'll notice that this line, it has an equation, and the equation should look familiar. The equation follows the format of y equals mx plus b, where, oops, I didn't mean to click that off, where m equals the slope of the line. Now, you remember slope refers to how steep a line is, and b is equal to the x intercept. Sorry, I can't type today, apparently. And so that's the equation for our line. Now, the R-squared value tells us how good of a fit this equation, so 1.108x times x plus 3.19 is to our data. Now, an R-squared value is on a 0 to 1 scale. An R-squared value of 1 indicates a perfect fit of that equation to our data. An R-squared value of 0 equals that that equation does not fit our data at all. So the way we interpret our R-squared value here is it's 0.997. It's pretty dang close to 1, which means that this equation is a really good fit for our data. Now, that's not super important for this course, but it will become important in subsequent courses you take. So just as a FYI, which is why I'm covering it in chemistry with you guys. So that's the equation, right? Now, let's go back to our worksheet. And let's go talk about question number 9, because I think this one will give you the most difficulty. So let's write our equation down here. Our equation is equal to y equals 0.108x plus 0.319. That's our equation. Now, in this instance, y is equal to mass in grams, and x is equal to volume in centimeters cubed, because that's the data I put in, right? Mass in grams, that's on the y-axis, volume is on the x-axis. Now, the question is asking you, if you only know the mass, how can you figure out the volume and the density of a cylinder? Well, the reality is we can actually use the equation we just wrote right here, because in these three examples here, I gave you a mass. If we know the mass, we can solve for x, because x is the volume. And once we have the volume and the mass, we can then calculate density. So what we would do here is actually plug in these numbers. We know y is 1.25 grams equals to 0.108x, x being volume, plus 0.319. Did I get that right? Yep, 319. And all we need to do is solve for x. And so x will end up equaling, in this case, 1.25 minus 0.319 divided by 0.108. So that would give me my volume, right? Because volume is that. And to calculate density, we know D equals mass divided by volume. Oops. And all we need to do is plug in our mass. So density is equal to mass, which is 1.25 grams, divided by whatever the answer to this is. So x. So pretty straightforward. So just some handy dandy tips to save you some time, to show you how Excel works, to show you how to use Excel to save yourself some time, because, you know, a lot of this math would take you a long time without it. So hope that was helpful. If you guys have any questions, please let me know. But otherwise, hope you guys take care.